thought I charged this thing. Wait, hold on. Lens cap. There we go. Video journal, August 3rd. We're en route to Mars. Earth is getting smaller and smaller. It's kind of weird not being close to anything, just blackness everywhere. I've been keeping busy. I mean, despite all the mission preparation, I've had a lot of me time. There's a lot of things I miss, but I gotta admit, I'm getting pretty anxious for our arrival. The crew has been great. Even though I do miss my family, I kind of feel like I have a second family here.
Hey.
Hey!
About time for our propulsion test, yeah? What's that?
Well, we've got wastewater management recycling efficiencies, solar panel photocell status reports, and a letter to my mother.
Ah, I didn't know it was mail pickup today.
Very funny. I'll give them to her when we get back.
Hey, you could put someone's eye out with that.
I've got an incoming message. Relay from the raw helioscope.
Roger that. Stand by. Captain, we have an incoming message. Looks like a storm warning.
Here it comes. Oh boy.
What have we got?
At 08:36 hours UTC, the raw helionet detected a large coronal mass injection with accompanying X-class solar flares.
Okay, region and trajectory.
Equatorial range, 7 to 36 degrees heliographic north, arching into the ecliptic. 73 to 81 degrees west, heliolongitude. It's definitely coming our way.
Audio incoming.
On speaker.
Houston, alert status 1. Hope the ride's going well for you today. I see we picked up a major solar hiccup headed in your general direction. Safety is recommending alert 1 precautions. Repeat, alert 1 precautions.
Houston Interceptor, copy last. Alert 1 precautions. Expecting increasing communication disruptions, but please continue forecast updates every 30 minutes. Over. Okay, begin power down protocols for all non-essentials. I'll tell the others. Then grab your personals and head for the storm shelter. Secure in 15 minutes, all right? Let's do our jobs.
Can you stow this for me?
Sure.
Okay, all accounted for. Lock it down.
Come on.
So what have we got here?
All the exterior radiation detectors on the spacecraft relay their information through here. This way we'll be able to see when and where the greatest effects are.
And also, how long we need to stay in here?
Don't look so nervous.
Yeah, well, a solar particle event this big would have killed the Apollo astronauts if they had been cut out and the moon in it.
We've got lots of protection. And besides, technology has come a long way since the Apollo, Shuttle, and International Space Station days.
Remind me again?
Well, for one thing, we have more accurate forecasting based on the solar cycle. The sun goes through a cycle roughly every 11 years. The cycle ranges from solar minimum to solar maximum. At solar minimum, the sun's magnetic field is less chaotic.
That sounds encouraging.
You'd think, but a less chaotic magnetic field means we're more exposed to galactic cosmic radiation coming from outside the solar system. At solar maximum, when the sun's magnetic field is more chaotic, it tends to scatter galactic cosmic rays, shielding us about twice as much. So that's why we planned our trip to Mars closer to the solar maximum part of the cycle. More protection from galactic cosmic rays.
This is good. This is making me feel better. Keep going.
All right, well, in general, traveling during solar maximum is good, but then we have to worry about solar storms like this one, which are obviously hard to predict. They can come more often during solar maximum, and they can come unexpectedly.
Don't I know this?
Right. So that's the trade-off for traveling during solar maximum.
Solar particle event, sunstorms.
We have first readings.
Starboard aft and a little bit forward on Module 4.
That's close to crew quarters. To us.
Just wait, it'll get worse before it gets better.
You were saying?
Right. We also have our own radiation shielding. Remember what they told us in training?
If you're going out into the rain, bring an umbrella.
A what?
Picture this. It's raining outside. You'll get hit by the raindrops and get wet unless you brought an umbrella to shield you from the rain. But of course, it has to be a good umbrella. Lightweight, easy to carry around, but strong enough not to break. And it can't have any leaks, rips, or tears where the raindrops could get through.
Confused here. Are we talking rain or radiation or radiation or what?
We're talking metaphor here. With particle radiation in space, it's the same. We must have good shields against these cosmic raindrops, or our interplanetary crews could get lethally dosed with radiation. Radiation shielding must be strong and light so we can build spaceships out of it. It must also be good at absorbing the energy of particle radiation. With radiation shielding, there are really 3 things to consider. 1, the environment outside the spacecraft where the galactic cosmic rays and solar particles are. 2, the environment inside the shielding material itself. And 3, the environment inside the spacecraft where the people and the food and the water and the computers are, the stuff we want to protect. When high-energy particles slam into the walls of our spacecraft, they create little holes or tunnels, but they can also create showers of secondary particles dislodged from the original material. And these can be harmful as well if they get inside the spacecraft and strike our astronauts. So the trick is to have a shield with real stopping power. Materials that will absorb the particles' energy before they reach the inside of the spacecraft, and that won't splinter into harmful secondary radiation. It turns out the best materials for the job are those with lots of hydrogen in them. Hydrogen-rich substances are best for a very simple reason. Hydrogen atoms have 1 electron and 1 proton. That means it can absorb energy from the incoming radiation, and with only 1 proton, it doesn't fragment into secondary particles like other materials do. Hydrogen-rich materials are the best for keeping radiation on the outside from getting into the crew compartments on the inside.
And our hydrogen-rich umbrellas are...
We have an aluminum shell for the entire spacecraft, which is very densely packed nuclei. Good for blocking particles. We also have 4 inches of polyethylene shielding everywhere, and 10 inches here in the storm shelter. Polyethylene is hydrogen-rich. It's the same stuff plastic grocery bags and kitchen cutting boards are made from. Add in lining, carbon composites, and new plastics. Plus we got food and water storage tanks, liquid hydrogen tanks clustered around the crew compartment hall. Breathe easy. Besides, we're well within tolerances.
Yeah, okay.
Get comfy. I predict we'd be here for about 3 days.
Care to make it interesting? I'll wager we're here for 4.
What are the stakes?
How about galley cleanup for a week?
And laundry.
You're on.
It's incredible, isn't it?
Not bad.
So we survived our journey, at least half of it.
No major malfunctions.
Except for the flusher in bathroom C.
No major illnesses.
Except, I do miss my family.
1 solar storm.
1 3-day solar storm. Thank you very much.
Hey, I paid up. No need to rub it in. Besides, next time, and there probably will be a next time before we get home, you'll be doing my laundry.
Dream on. But for now, we've got a red planet to explore.
Yes, we do. What's on your list for today?
Well, I've got excursion gear to inventory, environment suit tests to run, and I'm making lunch.